In this video, I'll show you how to create a Tic Tac Toe game with a fully working AI that plays defense and always aims for the winning spot. We're going to code the entire game line by line using Pygame in this 30-minute video. First, we'll start by importing the libraries we'll be using. So first, we're going to import the Pygame library. So import Pygame. And it will provide us with computer graphics that we'll use to create our visual game. And then we're going to import an exit function. So from sys, or in a new line, from sys import exit. And so the exit function allows us to terminate our program cleanly when the user closes the window. And then finally, from random import choice. This will later help us with the AI and allow us to randomly select one of the squares on the tic-tac-toe board. Alright, so before we can actually use anything in the Pygame library, we need to initialize it. So I'm going to type pygame.init, and this basically initializes the Pygame module, and this is essential because Pygame needs to set up various subsystems like the display, sound, and input handling. Alright, so now let's create our game window. Down here, screen is going to be our surface variable. It will represent the actual displayed screen. And we'll set it equal to pygame.display.setMode. And in here, we have to pass in coordinates, and that will be the width and height of our screen in pixels. So I'll do a 500 by 500 pixel window. And then finally, let's give our window a name. So we'll do pygame.display.setCaption, and we'll call it Tic Tac Toe. Alright, so now all games have a game loop that keeps running. This helps us constantly check for input and update the screen. So we'll do while true. This creates an infinite loop that will keep running until we explicitly break out of it or quit the system, which we'll do using the exit function later on. And this is basically the heart of our game, and everything that needs to happen continuously goes inside this loop. So first, we're going to run pygame.display.update. So each time this loop runs, we want to update our game. Specifically, we want to update the screen because this is what the player sees. And so this refreshes the entire display surface to the screen. Without this, any changes we make to our screen won't actually be visible. So this should be called once per frame, typically at the end of the loop. And then we also want to be able to control our frame rate in the game, which is the number of times this loop runs, or the number of times the game updates in 1 second. And this makes sure our game doesn't run too fast and uses up unnecessary computer resources. So to do that, we'll come up here outside of the game loop, and we'll create a clock variable, and we'll set it equal to pygame.time.clock. Make sure that clock, the C is in caps, and this will be a clock object that we'll use to track time. So to actually set the refresh rate, inside our loop, we'll add the clock tick to limit our FPS. So we'll do clock.tick, and we'll set the frame rate to 30. And so this will make sure that our game loop doesn't run more than 30 times per second. This prevents the game from consuming too much CPU and makes the game run at a constant speed across different computers. Alright, so let's also quickly set up the exit function and the quit function so we can safely close out of the program. We need this because we're working with a while true loop that runs forever. So first, up here, we're going to type for event in pygame.event.get. So basically, in Pygame, multiple events happen at any given moment, and some are considered special or important events, and those are stored in this list, pygame.event.get, and we have to iterate through each one of them and check to see if it's a desired event. So to do that, we'll do if event.type is pygame.quit, we want to do two things. First, pygame.quit to close Pygame, and then the exit function to exit the while true loop. Alright, so now we can finally work on what's on the screen, and we first need to create the background color. So we'll come up here, and this will be the first thing in our while true loop because it's our background, and we want it to be at the bottom. The way it works is in Pygame is that whatever you draw, as you go down, it layers on top of each other. So we want to do screen.fill, and then I have this a bluish color that's going to be our background. Oh, and this should be text. Alright, and then this will also make sure that it clears anything that was previously drawn on this screen. Alright, so now for the actual Tic Tac Toe board, I'm going to do this using a class, so we'll have control over each square, and it's going to help us place the X and O's. So up here, we'll create a class, and we'll call it board, and we're going to inherit from pygame.sprite.sprite. This gives us access to the useful methods for collision detection and group management and stuff like that, and it will basically help us later on. And so first we need to initialize the instances, so def init, and so all of them taken self, and then we'll have 3 additional arguments: the x coordinate, the y coordinate, and the relative location on the chart. We'll call this the code, and the code will be a number from 1 through 9 that identifies which square this is on our tic-tac-toe board. And so first we need to run super.init. This calls the parent class's initialization method, and this is necessary when we're inheriting from pygame.sprite.sprite, so we can properly set up the sprite and have it function. And so first we'll assign the code as an attribute, so self.code equals code. This will store the position number as an instance variable, and so this will help us identify which square is which later on outside of the class when we're checking for wins or handling clicks. And so for the sprite itself, all sprite classes need an image attribute and a rect attribute. So self.image will hold the visual representation of our square, and I'm going to create a square using Pygame, and I'll do that by pygame.surface. This will create a surface, and the size will be 100 by 100 square. And I'm gonna add one more argument. This is pygame.srcalpha. This is a flag that enables our per pixel alpha, which allows it to be transparent. And then for the actual rect attribute, self.rect defines the position and size of our sprite on the screen, and we'll set it equal to self.image.getRect. And we also need to tell the program the coordinates, so top left is equal to x comma y, and this will create a rectangle with the same dimensions as our image and positions it so that the top left corner is at the coordinates x comma y, and this will be useful for positioning the sprite and detecting mouse clicks later on. And then to actually draw and create the square, we want to do pygame.draw.rect, and this will be the self image, we'll give it the color white, and the rect will be self.image.get rect, and the border width will be 3. That will basically be the outline. And now let's actually create our 3x3 grid of squares. And so to do that, we'll generate this when the game starts. So first, let's create a variable called start y, and we'll set it equal to 100. So this will set the vertical starting position for our first row of squares. We start at 100 pixels from the top to leave some space for our future potential game over method. And we're also going to set the start x at 100. And this will basically center our 3x3 grid on our 500 by 500 pixel screen. And so now let's create the group, the sprite group. So Tic Tac Toe, that's what I'll call it. And I'll set it equal to pygame.sprite.group. And this is a container that holds multiple sprites. It will allow us to perform operations on all our board squares at once, like drawing them or checking for clicks with the mouse. And then now to actually get into creating the 3x3 grid, we'll first create a variable called number of spots. I'll explain this later. And available spots. And this will be an empty list. I'll also explain this later. So now we're going to be using a nested loop for this. So for I in range 3, this will run 3 times, 1 for each row. And the variable I will be 0, 1, then 2, representing the 3 rows of our grid. We create another loop for I in range 3. And this will also run 3 times, and this will be for our columns. Oh wait, we'll call this A for A, because we don't want confusion between I and A. And so what we want to do is each time this loop runs, we want to first increase the number of spots by 1. And this basically means our first square gets the number 1, the second 2, and so on up to 9. We're going to actually have to create our instance. So Tic Tac Toe .add our board class, our instance, and the x coordinate will be start x plus, we will do it A times 100, and then the start y. And we'll change that later. And then the code will be num spots. So this way, at first, we'll change the columns every time by adding 100 pixels to our original start x value. The rows don't change, and then we give it the code which is corresponding to the number spot it is. And then we're gonna do available spots dot append, and we'll do num spots. And initially all 9 squares will be in this list. And then outside of this loop, we want to do start y plus equals 100. This is crucial, and it happens after we finish each row. This moves our y position down by 100 pixels for our next row. This is why we modify start y in the outer loop. We want all squares to be in the same row, but each row should be 100 pixels below the previous one. We don't actually change the value of the start x variable because we want all of the rows to start at the same x coordinate. And so now to actually see our board squares on the screen, we need to draw them in our game loop. So we'll come down here, Tic Tac Toe, which is our group, .draw, and then the surface will be the screen. So this will call the draw method on our sprite group, which automatically draws all the sprites in the group to the screen surface. This is one of the benefits of using sprite groups. We can draw all of our squares with just one line of code. Now let's try running the program and see if this works. There it is. Alright, so now let's get into the actual game aspect. And so first I'm going to come up here and we're going to create two Boolean variables. One will be called a player turn. This will dictate whether it's either the AI's turn or the player's. Then we'll do one more, game active. And we'll set this equal to true as well. And this will basically help us end the game and set up the game over message. And so now in the class, I also want two more booleans that are attributes of the board class. So we need to know whether each square is an X or an O. So we'll do self.x and we'll set this equal to false because at the start of the game, nothing's been selected, so they're false for both. And self.o is equal to false. Alright, so now we can go down here. And now we want to check for when the player clicks on the square. So we know if the player clicks, we want it to become an X. So here, when we check for events, when the player clicks, that's an event. And the way you check for is if event.type is pygame.mouse button down. So that's if the player clicks. And we want to check if it's player turn and game active. Player turn. Alright. So now if the button is clicked and it's the player's turn, we want to check which square it was clicked on. So we'll loop through each of the squares. So for spot in Tic Tac Toe, which is the group containing all the square sprites, what we want to do is if, and now we want to check if the mouse was in that square at the time it was clicked. So if spot, which is our square sprite, dot rect, which is the actual area of the square, dot collide point, and in here we want to enter the coordinates of where the button was clicked, and we can do that using event.pause, which is the position where this event took place. So we want to check this, which is if that square was clicked, and we also want to make sure that that square hasn't already been occupied. So we'll check that by doing and spot.code in available spots, which remember is our list of available spots. So if all this is true, we want to first do spot.x equals true. We change that boolean value because now it's claimed by the player, who is X. We want to also remove it from the available spots list. So available spots.remove, and then we use spot.code. Then we also want to do player turn equals false. And so now we want to actually have this show up on screen. So up here in the class, we're going to create a new method, def, I'll do draw, and we'll pass in self. So we want to draw either if it's an X or an O. So if it's an X, so self.x, if that's true, we want to draw two lines that make an X. So to draw it, we'll do pygame.draw.line, and the surface will be on the screen. The color will make it white, and the position, its radius is going to be 30. So the coordinates will be self.rect.center x and add 30, comma self.rect.center y and add 30. And then for the ending position, we'll do the same thing, except we'll change these to minuses. And we also need to set the width of the line, and I'll just do 3. So that's one line, and then we're going to do the same exact thing for the other line. And the only thing we're going to change is we're going to change one of these to a minus and plus, and I'll only do it for the x. It doesn't matter which one you do it for, just make sure that this time the x and y, if you're adding and subtracting, make sure you're adding to one and subtracting to the other. If self.o, So if it's occupied by the O player, we'll do pygame.draw.circle this time. And the surface will be screen again. I'll have it be white as well. And we'll do self.rect.centerx. Well, these are coordinates, so it needs to be in parentheses, comma, self.rect.center y. And then the radius will be 30, and the width of the line, which is a circle, will be 3. Alright, and then we need to update this in the game loop. So down here, right above where we draw all of them, we'll do first spot in Tic Tac Toe. What we're going to do is update each of them for the draw method. And so now, if we try this, let's run the code. There it is. And now we can't reselect because it's not player turn. So now that we've done that, let's actually work on the AI that will respond. And so with the AI, we also want it to be smart. So before we can do all that, we'll come up here. We'll do this at the top of the while true loop. What we're going to do is we're going to create 2 sets. One will be X spots, which is going to be an empty set for now, and O spots. And this will be an empty set for now as well. And so what we're going to do is we're going to iterate through each of the sprites in our Tic Tac Toe class. First spot in Tic Tac Toe. We're going to do if spot dot x. So if it's an x, we'll add this spot code into our x spots set. So x spots dot add spot dot code, and we'll do the same thing. So if spot dot o. So if it's occupied by if it has an o in it, a circle, we'll do o spots dot add spot dot code. So this way we have a set or a list of which ones are X and which ones are circles. And before we actually get into the AI, I'm going to come up here at the top. We're going to create a list. It's going to be a tuple list, and we'll call it possible combos. And I want to spell this right, possible combos. And so this is going to be a list of tuples. And what we're going to do is each tuple is going to be the combination of the codes of the tic-tac-toe board, which are winning combinations. So first we'll go horizontal. So squares 1, 2, and 3. If you have those, you win. Then another possible combination is 4, 5, 6, and 7, 8, 9. Now if we go vertical, we have 1, 4, 7, 2, 5, 8, and 3, 6, 9. And we also have 2 diagonal combinations where you can have 3 in a row. So 1, 5, 9, and 3, 5, 7. 3, 5, 7. So if the player has any of these, they've won. We're going to have a function which we'll use to determine what the winning if there's a winning move for that turn, for that round. So def winning move, and we'll pass in, we'll do player spots. So this is all the spots that player occupies at that point in time. So what we want to do is we want to iterate through each of the possible combos. So for combo in possible combos, we'll turn that combo into a set. So combo set equals set. And we do this so we can check to see if there's a winning, if a player has 2 in a row and it's really close to getting that third one. So what we'll do is if len combo set dot intersection and player spots. So what this does is it checks for how many values in these 2 sets intersect. And if this is equal to 2, which means if a player has 2 in a row, Then what we want to do is we'll create a missing spot variable, so missing spot, and that will be equal to combo set minus player spots. And this will give us the third one that player needs in order to win. And because this missing spot variable is going to be a set, because we're using two sets here, what we have to do is we'll create a new variable called spot, and we'll set it equal, we'll first convert missing spot into a list, and we'll extract the one term in there, which is the first term, and that will become an integer value, which we can later use. We have to do one final check. If spot is in available spots, then only we'll return spot, and if none of this is true, we'll return none. Alright, so now let's actually get to the player turn. So we'll come down here, we'll do if not player turn, and we also want to make sure game active. What we'll do is we'll check if there's any winning spots, winning move, and we'll pass in the AI spots it has, so O spots. And what we'll do is, if this is true, if it's not none, we'll do AI move is equal to winning move and O spots. And we'll do elif. So this first one is if it's attacking. If there's no way it can win in that round, what we'll do is it will check if it can defend from from the player winning. So if winning move, this time we'll pass in the player spots. So the squares that players occupied. Well, this shouldn't be colon. Then if the player is one away from winning, we'll tell the AI is equal to winning move X spots. And if it can't win, or the player can't win, then else we'll just have it do a random spot, so AI move, and this is where the choice function comes in, AI choice, and we'll pass in available spots, which is a list of available spots. And then after it does this, we actually need to set the spot.o attribute to true. So we'll first check for spot in Tic Tac Toe. We'll do if spot.code is the same as AI move. So if that square is the one AI picked, we'll do spot.o equals true, and we also want to remove that from the available spots list. Remove spot.code, and then at the end here we'll do player turn equals true. So now let's try running this and see if it works. Oh, it does. However, we need to add a delay, and so it feels more natural, because what's happening is all of this is running, and before the game actually updates, the AI does its turn without knowing what the player did. So first, at the end of when the player does it, we'll do AI start time is equal to pygame dot time dot get ticks. We'll set that up, and now we want to add one more condition, so we'll do and. So to delay the AI response time, what we'll do, we'll make it half a second. So what we'll do, and pygame dot time dot get tick, so the current time minus AI start time is greater than 500 milliseconds. Then only the AI can respond. So now let's try this. It responded. Yep, it's defending as well. Let's see if it defends here. Yep, and I obviously destroyed it. And alright. So now let's move on to actually ending the game. We'll do that down here at the bottom. So what we'll do is we'll check for all of the possible winning combinations for combo in possible combos. we'll first do the same thing we did. We'll create it as a set, combo underscore set equals set, and we'll pass in combo. And if combo underscore set, and we want to do is subset, and we'll pass in x spots. So we're checking if this combination, combo underscore set, which is one combination of the winning ones, if that is in the x spot set, that means the player has won, x has won. So we'll first do game active equals false, and message, and we'll set the message variable to winner, and we'll do x. We'll do the same thing for the O. So if combo set is subset, we'll pass in O spots, game active equals false, and message this time will be winner, and then O. And so if not available spots, which means if all the spots are occupied, we'll do game active equals false, and the message is tie. And now we need to actually put this on the screen. So what we'll do is we need to create a font for the text. So up here we'll do font is equal to pygame.font, and I'll just use the normal default Pygame font, and the size will be 80. And we'll come back down here and actually draw it. So we'll do if not game active, because we only want this showing if the game's not active. We'll have the message we called over is equal to font.render. Then we'll pass in the message, which we set up here. That's what we want to show on screen. This boolean variable, it doesn't really matter, and we'll have the color be red. So this creates our text surface. Now we need to create our rect equals over.get rect, and the center will be slightly above and on the center of the screen, and slightly above the Tic Tac Toe board. And finally, we need to actually add this on screen, and because this isn't a class, we need to do screen.blit. Blit is a traditional method, and then we'll pass in the actual what we want to show, which is our text surface and the rect value over underscore rect. Alright, so now let's try running this. There it is. It responds. I'll go down here. Oh, and now I have to, let's see if it wins. Oh, and it won. Alright, that was the game. Hope you guys enjoyed watching. Please comment if you have any questions.